But it is 2:30.
It is 2:30, so I don't know. Well, thank you all for coming, especially right after lunch. And the story or research I'm going to be telling you about today was inspired by this research we did. It was published last year, working with Larry Haney and colleagues, where we discovered several new species of Apamese forest mice from the island of Mindoro, and that formed an endemic radiation. And doing so, it was the evidence for the smallest island in the world known to have had in situ speciation in mammals, breaking the previous records of Mindanao and Luzon, also in the Philippines, obviously, and by about tenfold. So we went from about 100,000 square kilometers to 10,000 square kilometers. And this led us to ask the more broad question then, just how small an area is sufficient for speciation to take place, or for the flip side is how large an area is necessary for speciation to occur. And I want to emphasize that I'm talking about in situ cladogenesis, where you have a single parental species in an area, and then it speciates into two daughter species, which now share that original area. And islands are a great system in which to do this because we have this physical constraint, and that also eliminates a variety of other variables. And so it's not anagenesis, where you have a single species colonize an island and then diverge from its mainland ancestor. This is in situ cladogenesis then, and that's in situ single island endemic clades. So this led last year to a survey that we did in the same paper for a variety of vertebrate groups, the smallest islands with species known. And this is basically a literature survey because there has not been a systematic study of this, and identifying that for a variety of groups, around 10,000 square kilometers seemed to be the minimum, and Mindoro brought mammals into that range. So the geography of speciation has been studied in a variety of different ways, from species area curves to the relative frequency of allopatric and sympatric speciation, the spatial dynamics of gene flow, or patterns of diversification within regions. But understudied is this fundamental question of just how much space do you need? How densely can you pack species into an area as being a corollary to that? So I think what will become clear that I'll emphasize in this talk is the results have real implications for the latitudinal diversity gradient. And of course, the latitudinal diversity gradient is this ubiquitous phenomenon of higher species diversity near the equator and declining diversity towards the poles, the single most pervasive biogeographic pattern on Earth. And there have been a multitude of models to explain this pattern, and I've just sort of roughly grouped them by their sort of ultimate causes. And that can be latitudinal variation in rates of speciation, higher in the tropics. It could be simply due to the geometry or geodesy of the Earth and the position of continents, and have just be entirely random. It could be that tropics are older, bias dispersal into the tropics, or higher carrying capacity in the tropics, primarily explained by increased energy flow through the system. So the objectives of this study were to identify the smallest island with in situ speciation, and we focused on mammals and reptiles to start with because these were two groups we could collect the data on directly before expanding onto other groups, search for any patterns that appear, and then quantify the relative importance of or interaction among factors that are related to it. So for mammals and for reptiles, we use two different methods or approaches to screen for single island endemic clades to try two different approaches and see which one would actually work better and apply it to other groups. For mammals, we screened the entire phylogeny. We had a working super tree and mapped the distributions of all the species to identify candidate sister taxa or clusters that might represent endemic clades. For reptiles, we instead screened all of the islands for single island endemics and then scanned those for possible close relatives, particularly congeners, in all cases trying to verify our results by going back to the primary literature and individual phylogenies. We then categorized our confidence in these assessments as either confirmed good molecular phylogeny, likely, perhaps not molecular, perhaps missing some relevant taxa, or possible. And we looked at area, latitude, elevation, and isolation. And then we applied multivariate logistic regressions to the data. So you'll see this graph over and over again. This is the basis for all of the results as I'm going to present them. And there's a lot of information to pull out of this graph, and I'm going to highlight some of the main points. Area on the x-axis on a log scale, latitude on an absolute scale, x-axis. A couple of key points. Speciation is not common. In mammals, only 13 islands on Earth show confirmed evidence for speciation. Elevation and latitude in the logistic regressions are not significant, by the way, somewhat surprisingly, once you account for area. Then the big pattern here, of course, is that all those islands that are either confirmed and as well likely are in this upper left triangle of low latitude and large area. And there's a general pattern of, in the lower latitudes, smaller islands, and as you go to higher latitudes, you see a few larger islands in play, implying a latitudinal effect between latitude and area. Now, there are a couple of outliers here, islands that are in the tropics and appear to be large enough based on other islands to have had speciation, but we don't see speciation on them. And interestingly, most of those are land bridge islands. So, Sumatra, Java, Taiwan, Hainan, also New Ireland and New Britain. And so these were areas that were in fact connected to the mainland or to a large body very recently. And so in this case, lack of isolation through connectivity has apparently suppressed speciation. Throw those out and you get a very strong pattern. There are a variety of other interesting things in this as well, and a few things like glaciation that I'm going to use in the discussion. Compare mammals and reptiles, and despite the very different physiologies of these two groups, you get very much the same pattern, except with reptiles you get a little more scatter and a few smaller islands in play. To focus on reptiles, I'll highlight first that there are more islands where we see that, 21 islands. And some of these outliers are New Zealand at moderate latitudes. There are no land mammals on New Zealand, so they were not in the data set. This white area down here is because I stopped showing at the first 500 islands. The extra 1,000 island here would just sort of mess things up, or it'd be hard to see. These two dots, that are these smaller islands of Mayotte at around 500 square kilometers, and Alduri at 137, which is just off of Yemen, which I'm actually rather skeptical of. There are these sister species geckos, but I think that still needs a little more investigation. But it's a lot smaller than Puerto Rico, the previous record holder, which is up here. Focusing back on mammals, or using mammals as the example, because we have better phylogenetic information, at least more confidence in some of our phylogenetic information. We ran logistic regressions to essentially fit the probability surface on top of this two-dimensional plot and find that the 50% or inflection point in that curve to result in this line where everything, all the islands to the upper left have higher than 50% probability by this model. All the islands below have less than 50% probability of speciation. It's a little bit flatter than what I might eyeball, but we'll take it as a conservative estimate of the relationship or the impact of latitude on the minimum area needed for speciation to occur. I think that's actually a pretty profound potential outcome of the study. With this, for every 10, what this curve represents then is for every 10-degree increase in latitude, 2.2 times larger area is required for speciation. That doesn't sound like a lot, but over 40 degrees, just going to the temperate region, that's 24 times larger. So an island that may have speciation in the tropics have to be 24 times larger to have that happen if you're in around 40 degrees. Reptiles, there's a little more scatter. The line's a little bit shallower. Again, I suspect it might be an underestimate, but even here, going from equator to 40 degrees, it's a 10-fold increase in the minimum size for an island. Just to make another point, to emphasize the significance of, or the impact of area and latitude, instead of sizing the dots as I did, sorry, I forgot to tell you, they were sized by elevation. Just go back to that in case you want to reassess the curve for a moment. It doesn't tell you a lot. Here I've sized the dots by the number of reconstructed in situ speciation events. So that means looking at entire clades and counting up the number of speciation events that took place on the island. All these red dots are, of course, islands that have no speciation, and I plot them only so you can see them for comparison. The large majority of speciation that's taking place on all islands are just found on two, New Guinea and Madagascar, which is not terribly surprising, but the degree to which they dominate the pattern, I think, is. And so the other islands that do have speciation on them, some of these have one speciation event, and then maybe two or three or four. So even where it does happen, most of the time, it's not leading to any particular diversification. So, what does this say about latitudinal diversity gradients? Well, we essentially have controlled for, in a way, geometry, time. Essentially, these islands are randomly distributed with respect to time, and almost all of them have had sufficient time for speciation to occur. And there's no dispersal. So these models would not predict this latitudinal gradient. Speciation rates model, this might be consistent with, I think most consistent with simply the intrinsic carrying capacity of the ecosystems on these islands related to latitude. So, conclusions. We did not actually lower the minimum area for mammals from Mindoro, but we do actually have some likely candidates that with additional data, Bougainville and some other islands in Solomons, that might bring it down to about 5,000. Reptiles, we found at least 5 smaller islands, and some of them are much smaller than Puerto Rico, so that changes that record. Speciation is uncommon to rare, at least in situ speciation on islands. They do not contribute a lot to the diversity of the islands. Mammal-reptile patterns are pretty similar. Isolation is not significant except in the fact, in the observation of land bridge islands and the impact there. And this strong latitudinal area interaction. And I'd like to thank my funding agency and colleagues for discussion, and I'll take any questions.
I was wondering if any of your outliers might be explained by islands in which you can sea level changes in island area, or they're ones with steep shelves and so on.
I think that it's very likely that I'm absolutely sure that the paleo landscape will have an influence on a lot of these continents. And the next stage for us is actually to then start taking a more nuanced approach for that. A lot of that's hard to account for. I think in most cases it doesn't explain any of the major outliers. So I mean, the major outliers have distinctive, very distinctive circumstances that fall into other categories.
Perhaps I missed this. How do you account for observer bias?
In terms of observing whether the species is on an island.
Yeah.
So that is an issue. Mindoro, we've only discovered that it was the smallest mammal island because of research done, intensive sampling over the last 10 years on that particular island. So that is a major issue. I suspect that almost all of the new islands that we will discover with speciation, though, will probably be in small islands in the tropics, because that's what they're really studying. So the observer bias is actually probably working against these conclusions. See?
Is there any tendency for systems to be bumpers when they're dealing with that?
Any to what?
Systems to be bumpers when they're dealing with that?
I think it's probably the opposite idea. I think that you see something on an island that's a little bit different, you want to name it. And I think it's time to change rooms. Thank you.